Hello everyone, welcome to this video tutorial of PyCript. Today I will show you how to utilize PyCript for bypassing client-side encryption. Before we dive in, let's quickly go over on how to install the PyCript extension in our Burp Suite. So simply just open your Burp Suite and head over to the extension tab. Inside the extension tab, click on the BApp store and search for the PyCript. Once you search on the PyCrypt, you will find the PyCrypt. Select it and just click on the install button and you will be able to get started. So you can also install the extension through my GitHub profile as well. So just go back to my GitHub profile and select the PyCrypt repository and just copy the path, or you can just download this repository as zip file. If not, we can just copy the path and go back to our folder and open the CMD and just type the command as git clone and paste the URL which we have copied, and it will be downloaded in the same folder. Now just open the folder, copy the folder full path, and inside the Burp Suite extension tab, click on this add button and select the language as Python, and we'll select that part and we'll select this PyCript.py file and just click open and select the next button, and our extension is installed in the Burp Suite. Now you can see that we have two Burp Suite extension, one from the BF stream and one we have installed manually. So we can just move any one of this. Now so our installation is completed for PyCript. So we can see that we have a tab as PyCript in our Burp Suite as well. So before we get started with PyCript, we have to make sure that we have certain things already installed to work with Python. So how PyCript works? PyCript allow you to write your own encryption and decryption script. So you can write your own encryption decryption script and provide those encryption decryption script to the PyCript, and PyCript will use those script to perform all the encryption and decryption task in the background. So you can use any three languages. So as of now, PyCript supports three languages. So you can use those three languages. So it could be either JavaScript, Python, or you can use Java as well to write your encryption and decryption script. So we have to make sure those three languages are installed in our system. So we have to just very first verify that any of these three language out of these three, at least one of this language should be installed. So we can just go to that particular folder, or we can just open a CMD or terminal anywhere in our system, and we can use the command as node-v just to verify if Node.js is installed or not. So Node.js is required to work with JavaScript. Same we can use for Python as well. So we can just type for Python hyphen version and we can see that Python is already installed. So Python 3.11 is installed. So we can use any particular version as long as our script works. The version is totally depending on your choice as well as the libraries you are working with. Similarly, we can also see if Java is installed or not. So just to work with Java. So we can just type Java hyphen version and we can see that Java is also installed in our system. So we can write our encryption decryption script in any of these three languages. Okay, now for this demo as well, I have created a dummy application. So this particular dummy application I have created, it has some client-side encryption. So all the example we can see has some different approach as well. So where we will see how we can bypass all this using PyCript. So all of this has client-side encryption, and it also has SQL injection vulnerability. So we will see how we can use to bypass client-side encryption with PyCript. So in case you need this particular application, you can just go back to my GitHub profile, and inside repository you will find a repository named Django. You can just open that particular repository, and once you open, you can download this as zip file, or you can also just copy the URL and use the git clone to download it. You can also find all the installation in the readme file, and you can, once the install, you can just directly access the application and you will see the same page once you open the application. So we will just see how we can bypass all this and also run automated tools as well. So we will see how we can use PyCrypt to run automated tools as well. So now our PyCrypt is installed. So we can try for client-side encryption bypass. So before we do with PyCrypt, let's see how we can bypass client-side encryption without using PyCrypt. So we will use the browser BreakPoint mechanism and online script to bypass it. So let's just open any one of this example. So we will just open this example here. Okay. Now we will just enter any random credential and we will see that what exactly is going in this request. So we will just submit and go back to the box and we can see, yeah, we can see that our data is encrypted. We have entered the credential and the data is encrypted format. Even the response is also in the encrypted format. But if we go back to the browser and see the console we can see that the response is encrypted, but in console it is in plain text. So we know that the application is using the decryption as well at the client side to decrypt the response. So for that we have to just go, first task is to find the encryption and decryption logic. So one way we can do it, so we have to just go through all the file and search for the encryption decryption script. So one big way we can do is just click on our domain name or the IP address in some cases. So we can just click on our domain name and use Control Shift F to search in all the files loaded by this particular domain name. So we can just search for some strings like AES or encryption, decryption, or some libraries as well. So in our case, we can just try for searching for some random strings as well to just to get the logic of the application, encryption, decryption. So in this case, the application only has one HTML file, but in some cases, in a real world application, there are multiple JS files or HTML files. So in that case, we will need to search in all files at once. So we will just search for some strings like ENC or encryption. So you can see that we have this CryptoJS library, CryptoJS encrypt. So CryptoJS is one of the most popular library for client-side encryption. So we can use search for CryptoJS as well, or if not, we can just search for AES or some encryption logic name directly. So if you just double click, you can see that we have this encryption logic available. So it's using encryption. If we just scroll up, we can find that we have this decryption logic as well, since the application is trying for response decryption and request is in encrypted format. So if we just scroll down, we can see that the application is sending the encrypted body, and above we can see that the complete body is in JSON format. So it has created a JavaScript object and it has converted it into the Java JSON and it's passed to the encryption function, and we can see that we have this encrypted data in Burp. We have this key and IV available. So first one way is we can either modify with BreakPoint. If not, we can use some online encryption and decryption tool to perform the encryption and decryption. So we can just open a new tab. So I have created one CryptoJS based encryption decryption script, which use the same CryptoJS library. We can just provide the key and IV in that script and we will decrypt. So we will just open that as well. So we will just open that. So if you just open this URL, you will to find this CryptoJS with AES encryption decryption script. So we will just copy paste the key. We just copy the key here and paste, and same for the IV. We will just copy the IV. Yeah. Now we need the encrypted data. We'll just copy the whole request body and we will paste here and click on decrypt. We can see that we are able to decrypt the data. So we can use the same way to encrypt as well. We can just copy paste the key and IV, the encryption text box, and we will be able to re-encrypt and resend the modified request with the repeat. So let's just do that as well. Just copy paste the key and data, and we have now the encrypted data. We can just send this request to repeater, and we can replace the body. We can see that we got invalid request data since we have added a single quote in the request body and application as SQL injection vulnerability. So this is one of the approach we can use for encryption decryption wiper. Again, the issue is that we have to do this process again and again for each request, and even to modify a single parameter, we have to do this lengthy process rather than just directly modifying the request within the box. So we can use this approach. Another issue that this approach doesn't allow us for any automated tools as well. We cannot run this like on this particular request, we cannot run any tools like intruder as well. So another approach would be like we can use the breakpoint as well. So let's see how we can use breakpoint. So we have this client side validation which prevent us from adding any special character in the input box. So we can see in the JS code we have to just find some logic. So we can see that application take the data and then pass the complete request data to this encrypt function. So here it takes the username and password and then it verify that it has any like special characters or not. And then we try to create a JavaScript object for the username password and then it create a JSON data. So we can add a breakpoint here as well. So if we just add a breakpoint and click submit, and we can see that the browser is stopped on that particular function. So we can use console to modify the data. So we can use console if let's just forward it. Okay, now we have the data in the login data function. So we can see that the login data has username password in JSON format. So it is currently in JavaScript object. So we can just modify the value using console itself, or if not, we can just directly replace the value on the right side as well. So we can just double click and modify the value from here. So let's just add a single quote. And let's just forward the request. So the application should encrypt the updated data. So okay, so it should work. Let's see. Okay, it's not working. I think we have made some mistake to modify later. Let's just forward it in the box. So okay, let's go back. Okay, we can again just update the request. You can see, okay, so we have modified the variable username password rather than the modifying the data within the login data. So we have to modify the data in login data since that login data is passed to the encryption function. So we have to modify from login data. So we will just modify data. Okay, we will just modify the username and we will just add a single quote. Okay, and just forward the request. Now we can see that we have the username change. So we have the single quote in the username. And if we just paste the same in console, you can see that our data is updated. Now this data is not encrypted yet and we have updated the value. Now if we just go back to the bug, we can see that this time we got the invalid request data since we have added the single quote in the username parameter. So this is another way we can just perform the encryption and decryption. Okay, so now we are able to bypass the encryption with this breakpoint method and this online script. So we have used this online script to bypass the client-side encryption as well as we have used the breakpoint mechanism to bypass encryption within the browser itself. So one of the challenge here is that we have to do this process again and again. So even we have to modify a single parameter or single data as well, we have to just go back to the script or the browser to perform the encryption decryption again and again. So how PyCript solve this? So PyCript allow you to do all these tasks within the Burp Suite. So you can just bypass the encryption within your Burp Suite. So you can also modify your data in the plain text within the Burp Suite, and if you modify anything, the extension will handle everything in the background. So how PyCrypt solve this? So PyCrypt allow you to write your own encryption and decryption script. So you can write your own decryption scripts as well. So for that I have created a GitHub repository as well. So you can just go back to my GitHub profile and search for the PyCrypt template. So if you just open this PyCrypt template, you will find all the dummy encryption decryption scripts available in three languages. So extension support all these three languages: Java, Python, and JavaScript. So you can just download this repository. So you can just do git clone, or if in case if git is not available, you can just download it as a zip file as well. So as of now, let's open the git clone, and we have this PyCrypt template installed in our system. So we have some dummy script in all three languages for encryption decryption. So you can use those as well. So since PyCrypt use the JavaScript, Python, and Java, so we need to install certain libraries as well. So if you just scroll down, we can see that for Java, jar file is provided, so it has all the required libraries. So you don't need to do anything unless you want to change anything. For Python, we have to install certain library for encryption decryption. Same for the JavaScript, so we have to install those libraries as well. So as of now, in this video, we will only use the JavaScript and Java. So for that we will use JavaScript libraries. So for that we have to just install this library. So you can see in the package.json we have this three library mentioned which we need to install. So to install this library, we can just type the command which is mentioned in the readme file of this PyCript template. Same for the Python as well. If you are trying for Python, we have this one library we need to install in our system. So for that, we will just open the CMD in the PyCript template, and we will just type npm install as mentioned. And you can see that all the libraries are installed. And if you just go back, you can see that we have a folder as node module. So it has all the libraries installed. Now, if you just open any one of this encryption or decryption file, so you can see that till line number 8, line number 11, we have the default code required for the packet. We will see that later. Next, we have this key and IV, and later we have this decryption logic, sorry, which is trying to decrypt the data using crypto.js. If you just go back to the browser and we see our encryption decryption logic. So if you just scroll, yeah, so here we have this our decryption logic, and we have the same encryption decryption logic here. It's using the same crypto.js library. We are using the same mechanism, so we just need to replace the key and IV. So we just copy paste the key and IV and replace in our file. So in most cases, mostly in your web application, you can just copy paste your encryption decryption logic completely. In some cases, you can just use the logic within the original JavaScript file from your application with some minor changes to make it work with the PyCript. So we will just copy paste the key and IV in the encryption file as well. I believe the key and IV same. I believe, yeah, it's same. So we can just copy the path, and we will just try to load this encryption decryption script in a PyCript. So as of now, we are only doing for request. So we will just load this file in request. So let's just select the file. Now just make sure that now we have selected the JavaScript file. So we have to make sure that we have selected language as JavaScript. And as of now, we are only doing a decryption for body. And as of now, we only want for request, not for response. Now we have to select the request type. So if you just go back to the request, you can see that our complete request body is encrypted. So in that case, we can select the complete body, and we can see that we have this PyCrypt tab. If you are not able to see the PyCrypt tab, even after doing all this configuration, so go back to your Burp Suite and check if your domain name is in the Burp Suite scope or not. So PyCrypt will only work in those domain or IP address added in the Burp Suite scope. If you remove, then you can see that it's not showing. If we just go back and enable this, and again now it's showing the PyCrypt tab, and if we just click on it, we can see that we are able to get the plain text data. So if you just go back to the intercept, okay, just turn on the intercept and just if you just submit the form, you can see in the PyCrypt we are able to see the decrypted version of the request. And if you just go back to the browser in the console, we can see that as of now we are getting invalid credentials since we have not modified anything in the request. So if you just intercept again, and if we just try to add a single quote and the username and forward the request, if we just go back to the proxy history, and we can see that we have this original request and edited request option. So if you just copy the original request body and verify if the content are more changed or not, so we can just paste, and we can see that it's not matching, so the content is changed by the extension since we have modified the request. And if we go back now, yeah, so from the response, we can see that this time we got invalid request data instead of encrypted data as invalid credentials since we have added single quote and it's vulnerable to SQL injection. So we just submit the request and send it to repeater. And if we just directly try for SQL injection here within the repeater, we can see that we got this invalid request data. And if we just try to bypass the login, and we can see that we got a different response. And if we try to decrypt it, so remember we can do decrypt the response with the extension itself. As of now, we will see how we request work. Later we will see how response work. So now we are able to bypass the login with SQL injection using the PyCript. So we can see that we are able to decrypt as well. So if you just select the script string here, and if we just select a decrypt string, and you can see that we can decrypt the strings as well. In some cases, if you are not able to do with PyCript, you can just select the script, select a string as well. Now we can do that for request as well. So the string encryption decryption is not limited for response as well. So if we just copy this plain text data from here, if we select anything from the request as well, if we try for encrypt, we can see that we got the encrypted data for this plain text request body, and we can just replace this as well in the request body. So it is not limited with the request or response or even the body itself. We can do it from request, response, and body in header as well. So if we just try for header, okay, so decrypt string won't work, it's already imprinted. So we can just, as mentioned, we can try directly for string encryption decryption as well. So one thing to note here is that if we try for request encryption decryption within the request itself, it will use the script from request. In case the script is not available for request encryption decryption, it will use the response. Same for the response. If you select any string from the response, it will use the response encryption decryption file. If that particular file is not available, or due to some error it's not working, then it will use for request. So it's vice versa. If you select on request, it will use the request first, then response. Let's see how we can run the automated scanner as well. So you can see that as of now the request body is encrypted. So it does have parameter, but all are encrypted. So if you just send this request to Bob scanner, and you can see that as of now Bob is not able to detect any parameter in the request body, since our body is encrypted, and it won't be able to add any payload to it. In case if I add any payload to the request body, the server will reject the request because the server won't be able to decrypt it, since it has Bob has modified the data. So if we just wait for a few minutes, we will see that Bob won't be able to detect any SQL injection or any vulnerability. No, as of now, Bob has not added any payload to the request body. Okay, so you can say that the audit is finished, so Bob is not able to detect anything. So how we can do with PyCrypt is, so we can just right click and send this request to PyCrypt, and we have option as decrypt request. And if we just go back to the PyCrypt and request, you can see that we have this decrypted request stored in this table, same as proxy history. And here we have this decrypted request. You can just right click and send this request to active scanner. And if we just go back to logger, we can see that Bob scanner got this plain text request, but again the server will reject the request and server expect an encrypted request. So what we want Bob to get a plain text request, add a payload in the plain text request, and we want extension to get that request with payload and update the request accordingly, add the encryption and everything required, and then send the updated request to the scanner. So as of now we will just pause the scanner. And if we just go back to the PyCrypt, and if you select the config, you can see that we have this option as auto encrypt, which will automatically encrypt the request. As of now, the button is not enabled. So first we have to select the tool. So let's select tool as scanner and extender. And we can see that button is enabled. We just turn it on. And if we send the same plain text request to scanner, if we just go back to the logger, it's not sending. I think we have paused the scanner. So let's resume the scanner. Now you can see that the request body is automatically encrypted. So you can see that request bodies keep getting changed since Bob got the plain text request and it's trying to add payload in the request body parameter. And even the response, we are not getting any error due to the encryption, since extension will automatically encrypt the request as soon as Bob enter the payload or anything. So let's wait if Bob is able to detect or not. So even if Bob is not able to detect or it's able to detect, we now know how we can use PyCript for Bob scanner as well. So same we can use for intruder as well. So we can send the same plain text request to intruder and select the tool type as intruder in the to encrypt within the PyCript, and it will automatically encrypt the plain text request from intruder, and we can perform the attack within intruder with plain text. And we can see that the Bob is adding some payload here, and we have this encrypted version of it. Now we have another this option as well. So if you know that we have to modify the data with PyCrypt tab. So in that, if it is not required, if you don't want to modify data with PyCrypt tab, you can send the plain text request to the repeater. And if you just modify, you can see that plain text request as of now going from repeater. So if you select the tool type as repeater here, and you can just add like perform the testing with plain text without using the PyCrypt tab, and your request will be automatically encrypted even from repeater, just in case you don't want to use the PyCrypt tab in your request or response. I think it's not able to find SQL. Maybe we can just as of now cancel as we know. Let's, or maybe we can just try again. So let's just send this request. So let's send this one to bug scanner. Now our auto encrypt is already on, so let's just wait if it's able to detect. Maybe we can configure bug scanner to only try to find for SQL, exclude all other vulnerabilities. Now you can see that bug is able to detect the SQL injection vulnerability due to the plain text request was provided. Similarly, we can try for SQL map or any command line tools as well. So we have to provide the plain text request to SQL map, and we have to make sure that SQL map send all requests to Burp proxy, and we have to select proxy in the auto encrypt within PyCrypt. So all the payload added by the SQL map should be auto encrypted by the extension. So we can just try that as well. So let's just copy any one of these requests. So let's try for SQL map as well. So we can just save this request in a file. Now remember, we are passing the plain text request here to the SQL map. Since so SQL map will be able to add any payload to the request parameters. I'll just send this all the requests from the SQL map to Burp proxy. So we'll just add the Burp proxy IP address. And you can see in the Burp proxy we have all the requests coming from the SQL map. So now let's turn on the proxy auto encrypt. Let's cancel this and restart the scan. And if we just go back to the Burp proxy, again we have this plain text request coming from the SQL map with payloads. And if we just go back to logger, we can see that requests are getting encrypted even from proxy. So let's just cancel as of now. Now we know how it works, so we just cancel this. Now another issue is that if you notice within the PyCrypt tab in the decrypted request, if we right click and send any request for a scanner, we won't get option to configure the scanner as we get from the proxy or the repeater. So if you just see here that we have this audit option where we have configuration option as well. So what we can do is we can use another option within the PyCrypt. So if we as of now just go back. Okay, so just see right click and you can see that we have this another option as resend HTTP request. So in case you want plain text request in your BApp HTTP proxy history, or you want any other configuration, or you want to perform any other task with plain text request, but you don't want plain text request within your Burp Suite PyCript tab, you can just configure your Burp Suite to send all the requests from Burp Suite to another Burp using upstream proxy configuration. So if we just go back to the BreakPoint settings, in the network configuration, you have this connection upstream proxy server. You can just configure like it will send all the requests from this bug to another bug, and you can just right click on this all the plain text request and select a resend request, and extension will resend this particular request, and you can capture all the requests from this bug to another bug in the proxy. You can see that in the logger we can see that this request was repeated. Just in case you want all these PyCript request, decrypted request in your BApp proxy history, not in the PyCript decrypted request. So if we just directly try for active scan, you can see that we don't get any option for the scanner configuration. We have to manually do it. But if we try from proxy history, we get this all the option to configure before starting the scanner. So in case you need it, you can use that upstream proxy and resend request option. Now, if you just see for the response, you can see that we are able to decrypt the response. If we use for response decrypt string, if you select complete request body, we are not able to decrypt it. But if you only select the request data, we can see that we are able to decrypt the data. The reason is the request body has double quote, and our script doesn't as of now handle the double quote. So for response, we can use the same script for which we are using for in the request, but for response, we have to handle a double quote as well. So you can see that we are directly passing the plain text request to the decrypt function, crypto.js library to decrypt it, but it will have double quote. So we have to first make sure that we try to remove the double quote before passing it to the decrypt function. So let's just try to remove the double quote, and we will use the same script for response now. So let's just take the data. So you can see that we are getting the data at line number 15. So we have to just remove the double quote from the start of the data and the end of the data. So we'll just try to slice the data. We can also verify from the browser itself. So if you just copy paste this data, now if you just try to print the data, the same data, you can see that the data has double quote. Now let's try to remove the double quote from the start and end. I think we have made some mistake. Okay, now you can see that we are able to remove the double quote from the start and end, and we can pass this data to crypto.js for decryption purpose. So we can just copy the code maybe. Now just copy the path, and we will use the same. Now remember, this script won't work for request now because we are modifying the data provided by the extension. Either we can have separate script for request as well from response. Now another requirement is that the content should be in JSON. So if you are trying for response, the content type should be JSON. If the content type is not mentioned explicitly, then we have to make sure that at least the body has JSON data. So in this case, okay, so we have forgot to add. Now again, remember our complete body is encrypted, so we are selecting the same for response type. Why tab is not showing? I think there are some issues why it's not showing. Select the response. We are getting some error. Okay, so since we are providing the same script to the request as well, and it's getting some error to decrypt the request, because of that it's not showing. So as of now, just turn off. We have turned off for request, and we are only trying for response. Now, if you want to like perform for both request and response, we have to make sure that we have two different separate scripts for response and request. And now we are able to see the decrypted response as well. Now, since we already know that how our extension work and how we can decrypt the request with PyCrypt, let's see what are the major functionalities how PyCrypt exactly work, and we will see how we can write our own custom script as well. So first task is that when you install the extension to perform any task with the extension or to perform any decryption, the first is you have to select your encryption decryption script. So you have to write your encryption decryption script. There are certain requirements for your script so that PyCrypt works with the script as well. The next is you have to select the request type. So you have the first is the complete body. So as we seen in the last demo, where the application has complete request body encrypted. In that case, we need to pass the complete request body to our custom script. So what extension will do, will take the complete body and will pass this body to your script, and script will perform the decryption on this body and will give the updated body. There are some cases when your application at the client side generate random key and IV and send the key and IV within the body itself. So in some cases, your body will have the encrypted data and it will also have the key and IV as well. So in that case, you won't be able to have hard-coded value of key and IV. So in that case, you have to pass the complete body, and in your encryption decryption script, you can write your logic to get the key and IV from the request body. So in that case as well, you have to select the complete body since you want the complete body to be passed to your custom script. So another option we have is that a parameter value. So there are possibilities when the application try to send the data. It could be in JSON or form data, but only the parameter value is encrypted. So now you can see that we have this with dummy request where the parameter is in the plain text, but it has a value which is encrypted. So in such scenario, you have to select this parameter value since the parameter value is encrypted. So the extension will manually go through the each parameter value and will pass each value at a time to your script. You can use the same script which you have used for complete body, and you can use the same script for parameter value as well, unless and until your custom complete body has some different scenario which you have used. And if not, then you can use the same script for a parameter value. As another is that complete key parameter key and value. So there are cases the value is encrypted and the parameter name is also encrypted. So you can see that we have here parameter name and value both are encrypted. So extension will take the parameter name, will pass it to script, then it will take the value, then will again take the parameter name for the next key and value. So it will go through the each key and value and will pass it to the extension one by one. So another option is we have this custom request. So there are scenario when the application generates the client side, it generates the key and IV at the client side, but instead of sending the key and IV through body to the server, it's keep a header in the request. So it could have the request could have a header as key or IV anything which will contain the header and which will contain the key and IV. So in that case, you have to get the key and IV from the request. So in that case, extension will take the header and body separately. So it will pass the header to your script as well as the body. So you can write your own logic to go through the header and get the key and IV from the header and decrypt the request. Again, the one other thing that you have to remember is that if complete header is passed, so you have to make sure that body will be passed without being passed. So you have to manually pass the body. So another option is custom request and edit header. So there are scenario when the you want to edit the header as well, or it could be you want to remove any particular header, take the value, or add a new header, so you can use that as well. So if we just look into this particular script, you can see that first we are trying to use the CryptoJS library, and we are using this commander library. So commander library basically allow to get the command line argument. So if you just see that if you select the complete request body, so the extension will take the complete request body, will base64 encoded. So remember, even if your body is already base64 encoded, extension will do it again for its behalf, just to avoid any errors, and it will pass this base64 encoded body to your script. So it will run a system command. So basically, if we just see what extension will do. So I think we have modified the script so that just the response. So we have base64 encoded response. It will run the system command as node, and it will give the computer path of the script which we have provided. So if we just try to get the decrypt, so it will take the complete decrypt body. Since remember I mentioned that we have used commander library, which is for command line argument. So it will use -d and will pass the complete request body. And we can see now we have this decrypted version. So the extension will read the output of this system command and will try to replace the request body or header accordingly what you have selected. So the commander or library which we have used is basically allow us to get the -d and its value, which is basically a commander library. So if we just type -help, we can see that we have all the options available. So you can see that the extension is just trying to get the request body which we have passed through -d, and it will try to base64 decode it. So remember we have done the base64 encoding. The extension will do the base64 encoding. So the reason we're doing base64 encoding, let's see that we have this JSON body. So if we directly pass this body, or in case there are other bodies as well which might contain special character like a form data. The form data might contain special characters like AND character, which will prevent the command line script to run properly. So just to avoid such situation, the extension will do base64 encoding and will pass the base64 encoded data to your script. So in your script, you have to make sure that you first base64 decode to get the actual request body. So if we just look at this example, so you can say that in this case we have the special character such as AND. So if we just pass this without doing base64 encoding, you can see that we are getting some error that because of this AND character. So just to avoid such situation, the extension will do base64 encoding. So in your script, you have to make sure that you do base64 decode before doing any process, just to get the actual body. Same for the parameter value and parameter key value as well. Just you can use the similar script because it will take the parameter value one by one and will be 64 encode and will pass it to the script. You can see that we are trying to base64 decode it, and as we have seen in the last example, we have the double quote at the start and end. We are trying to remove it, and then we will decrypt the data. So we can see that we have passed this data, and then we will process with the decryption, and we are printing the output. So you can see that we have this console.log at the last line. So remember that the extension will try to read the output of the script. So make sure you don't print multiple things. If you try to print multiple data, if you have multiple console.log or print statement, the extension won't be able to read the actual output. Since we are only trying to get the updated value, so it should be only one print statement in your script. Now, if we look at the custom header option, so if you just go back to our GitHub repository with some demo script, so if we just open this demo script, we have this additional example, and here we have this custom request and custom request edit option available. So I have created some demo script how you can pass the header. So if we open maybe just Python, so we can say that in this case we are using rparse library just to get the command line argument. Now here we have -d just to get the request body, and we have -h to get the header as well. So we will use this script for our custom header as we can use this script for custom header. So you can see that here we have trying to get the key and IV from the header. We are just going through the header and parse the header to get the key and IV, and we are passing this key and IV to a decryption function. And you can see that we have only one print statement which will print the decrypted output from this script. Now again, this script is almost same. We are taking the date -d for request body and -h for the header. And instead of just seeing the header, we can see that we are trying to update the request header as well. And in this case, we have to print the header and body. So remember, in only on this script for edit header, we are trying to print a two statement, since we need updated request body separately and with updated request header separately. Here you can say that we have single print, but in this case we have two print just to get the updated header and body separately. In this script we have to print the output as a base 64 as well as the header as well. We have to print in the base 64. When the data pass and header pass to the script will also be in the base 64. So you have to decode in your script first both data and header will be base 64. So if you just open this documentation, so if you just go back to PyCript template, or even if you just open the PyCript repository, you will find the documentation link. So if you just open documentation link and go back to writing custom script, so you will find all the example how the extension will use the script, what are the data will be passed, and all three language you will find in the scripts as well. What are the required thing for the extension? So you can see that in this we are using parser as well as base64 encoding just to decode the data. And custom request type, you can see that the header will be passed in this format. We have -h and -d. The data will be base64 encoded, and header will be in the plain text as like a list. Now if you just scroll down the custom edit request header, so we have this edit request header option available. So you can see that in this case the -d value is base64 encoded, and if you scroll you can see that even -h the header are also base64 encoded. So in the custom request edit header and without edit header, in both cases the header will be different. So here the header will be in a list format, but in custom request edit header, the header will be passed in the different format. So you can just go back to your box and just copy the request, and the same format it will just be 64 encoded. So they are in your script you will get the same header as you see in the box. So if you just click here, you can see that we can split the header with the new line, and we will be able to parse the header and give it to the extension. Okay, so let's look at another example from our demo application. So we are again looking at the complete body example. So we have already covered the example number 2. So let's look at the example number 1. So let me just go back to the box. So you can see this in this case, the data is encrypted, but the data also has the key and IV. So let me just send this request again. So you can see that each request has different key and IV. Since the key and IV is different, the data is also different. So in this case, we have to use the complete body, and in a custom script, we have to get this body and parse the JSON data. And once the data is parsed, we have to get this key IV and then update the data with the decrypted data. So if you just look at the PyCript template which I have provided, so in the additional example, you can see we have a complete body. So we are taking the data as -d, base64 decode the data as mentioned, and then we are trying to parse data as JSON data. and then we are trying to get the key and IV, and then we are trying to get the data. Since our encrypted data is in the data variable, and then we are trying for decryption since we have the key and IV. Now if we go back to this and again use the same method, Control Shift Tab and search for AES, we can see that we are able to see the encryption code as well. So it's using the same of just it's trying to generate the random data. So it's trying to use the random key and random IV for each time we submit the form. So we can use the same methodology. In case you're trying for write, like if you try to write custom script, you can just copy paste the script and just need custom modification. So we can use this one. Now if you just look here, we are trying to print the JSON using the same methodology because if the user edit the data, if we edit any data in the plain text format with PyCript, we have to again encrypt it, and for that we need the key as well. So we are printing the updated data which has plain text value, but again we are trying to add the same key and IV as well. Just in case if we want to again encrypt it, we can do that. So for that we can just go back, go to the PyCrypt template, additional example, complete body. Let me just try with JS itself. PyCrypt. So it's encryption. And we are selected for decryption. Select the request here, language is correct. We are using JavaScript. And for response time, we will select as none since we only want for request, and we have already selected request type as complete body, and we can also verify that our domain name is already added as a scope in the box. So if we go back here, you can see that we are able to see this PyCrypt tab, and we can see that in the data we have another JSON as decrypted version of data, and we have key and IV as well. Now this time the response is in plain text format. So again, let me just try here. If I enter in special character, it's error that special character not allowed. So let me just send this request to repeater. Now we can again use the same approach for automation as well. Auto encrypt, send this request, or we can use this. Now just in case we want to try for SQL injection, maybe we send this request, we get invalid credit. Now we got invalid data. And you can see that we are able to log. Another thing to note here is that since the key and IV we are like in a custom script, we try to get the key and IV from the request body. So in this such case, if we try to select anything and try for decrypt, it will, okay, let me just try for, okay, let me try this one. If I try for decrypt, it won't work. It again give me the same data. The reason is in this case we have with -d we are only passing this data to the script, and the script expect the complete JSON data and expect the key and IV with it. Since the key and IV is not hardcoded, it won't work for the encryption and decryption of script or string with the right click menu. Okay. So let's look at another example which we have. So now we have another example for parameter value. So as I mentioned earlier, we can use the same script which we were using for complete body as well. Like for example 2. So example 2 for complete body, we can use the same script for parameter value as well. Since I mentioned that the complete body will be passed, if select the parameter value, each value will be passed as a single string one by one. So let's close this. A bit clear the data. So you can say that in this case, we have only the JSON parameter value is in encrypted. So only the JSON value is in encryption format. Now again, if I select the JSON parameter value, it won't work because our script expects the key and IV, since the key and IV is not hardcoded. So we can use the same script which we were using earlier. Only thing we need to remove it. Now we can just undo everything. Now if I go back to the browser, so it's using the same key and IV, the same encryption logic, just instead of complete body, it has only key and value encryption. So go back to the PyCript template inside AES CBC. Now the reason why I'm not using Python, since we have not installed any library for Python, and for Java, in case any modification is required, especially the key, let me check. So in case of Java, we might need to replace the key, or maybe not. Let me just try this one. So we will change the Java. Now remember, we have to select the jar file, not the Java or .class file. So first we need to select for encryption. So remember, I'm selecting the jar file. For decryption as well, I'm selecting the jar file. So let's see if we are able to decrypt it. You have to select the parameter value, and we can see that we are able to decrypt the data. Now we can see that we have used the Java this time. Again, let's see, we can decrypt it. We are again getting this. Now remember what I mentioned earlier, the request body has to be in JSON format. So in this case, the content type in JSON, but the request has this response has this particular double quote. So we have to write a separate script for response. So as of now, we will just ignore this, and we will try to decrypt. You can see that we got an error as invalid message. We got another message. So this time the message is different. If we just write paste it, okay, we still getting same message. Okay, so we are trying on password rather than on username parameter. Okay, now we can see that we are able to log in. Now we can use the same approach for automation as well. So let's look at another example. Just close this one. So another example, we have the parameter key and value as well. So if we go to the bot, we can see that the key and value both are encrypted. And if we try this one, we can see that since we have selected the parameter value, we can say that parameter value are encrypted. But in our case, the parameter name or the key itself is encrypted. Since the key and IV is same, we can say that from the source, we can say the key and IV is same. So we can use the same Java file which we were using for parameter value example, just change it to parameter key and value, go back, and now we can see that we are able to see the parameter name as well as decrypted version. And this, verify this one. We got invalid credential error. We got another message. Login success. We can use this response decryption script as well if you want, but as of now we can ignore it. Now for this one, this one is a little different. So in this case, if we just go back to the browser, check the source code. So you can see that the application try to generate the key in IV. So it generates the random key in IV similar to the complete body example. But in this case, instead of sending the key in IV in the request body, it sends as a parameter name and value as a header as well. So we need some way to like fetch the key and IV from the header. So if we just go back to the PyCript additional example, custom request. So we have this particular code available which try to, so basically take the header as well and body as well, read the header and go through the header and try to get the key and IV header value. Once you get the key and IV value, try to decrypt the body which we have provided. Now in this case, the complete body is encrypted. In case the complete body is not encrypted, then you have to manually handle the body. Then the complete body will be provided. If the body has each parameter value encrypted, so you have to manually do that. So let me just go back. PyCript custom request. We have to select JavaScript. Now we are selecting complete request. Now you see that we are able to decrypt it. Now if we open this decrypt file, you can see that we have not mentioned the key and IV value. We are fetching that data from the header itself. Now in this case, if you see that the complete body is encrypted, in case the request was like this, then in the JavaScript code of the custom script which you have written, in that you have to manually handle this one to go through the each parameter value and decrypt the value. Now in our case, the complete body is encrypted. We can just directly modify it from here. We can say that login successful. You can also verify it from here, logger as well. So you can say this was the body where we got login successful and we edited and the body is changed. Since the extension is entering the encryption in there. So another example we have is the custom request edit. So let me just clear it. So in this example, we can see that the request is encrypted. So let me just start with example number 2 first. So in the example number 2, you can see that the request is in plain text format. I'm getting this message as invalid credential, but if I change anything, maybe just a capital, I got another message. If I decrypt, you can say that I got an error that invalid signature since we have edited the request. If we go back to the browser and check the code of the application, so I take the user form data, create the JSON data for it, add the same in the request body, but at the same time it create an MD5 hash as well for this particular request. So you can see that we have a header as signature. So this is the original request. If we go to any website for MD5, we got this MD5. Just let me verify if it's same. So we can say that it is same. So it's using MD5 of this particular body. Now if I modify to admin 1, it gives me 400 requests. But if I take this, I got updated MD5 hash. And if I modify as well, you can see that the error is changed now. This time I'm not getting error as invalid signature. I'm getting error as invalid credential. So maybe we can try for we still got some error as invalid credential. Okay, so we are still getting the error. Okay, but as of now, we will just move to the PyCript. Okay, so in this case, we need custom request in editor since we need to manually in the script we need to get the hash of this particular request body and update this particular header. So if we just go back to the PyCript template, we have custom request editor. Now it's not just going with JavaScript again. So you can see we have this MD5 hash option available where we try to take the hash of the request body. But in this case, we are expecting that the data is also encrypted. So we'll try to decrypt as well. So let's first try with say example 1. We will go with this one JavaScript. We will select this You can see that as of now we are able to decrypt the data. You can see that we got the invalid data and that invalid data is gone. And we can see that we probably got the login successful message. And the signature is automatically getting updated. So if we go back to the log, copy the signature, you can see that signature is different in both the requests and the extension is able to update the request header as well. Okay, let's look at the final example which we have, which is RSC. So in case the application is using asymmetric client-side encryption, which we can also do that, we can bypass that as well since we are writing the custom encryption decryption script. But since asymmetric require both private key and public key, we need both the key. So in most of the cases, the private key will be stored in the server side. So if you just go to inspect and check the source, you can see that we are able to see the public key, but private key is stored at the server side. So one way is if we have the private key and public key, we can easily write the same encryption decryption logic the application is using. In most cases, we can just copy paste this particular encryption decryption code and modify it in a PyCript way. Another option is since we don't have the private key available, so only one possible option would be is to get the data in plain text in Burp Suite. So we have to somehow modify this JavaScript or HTML code to get the request data in plain text. So what we can do, so in the Chrome we have options. So in the Chromium based browser we can override the HTML and JavaScript source code file. So it won't work with the Firefox. So in the Chrome we have this override functionality. It will ask for the folder. So as of now I'm just selecting this PyCript folder. Select the folder. It will ask for the permission allow. Now we have this override folder available. Now just right click on it. Now we have this option as override content. We can override. Now we can use Control S to just save the file. Now one thing which we need to do is we can say that particular function we try to take the plain text data, take the public key. It will try to encrypt the data with public key and will return the encrypted data to that particular function code where this particular function was called. So we can see the username and password is getting encrypted. So to get the plain text data in our Burp proxy, we have to mention that we do not want to encrypt. We will try to return the same data, the same plain text data which was written. So if we try to refresh the page as well, we can see that our updated code is here. Let's try if it's working or not. Okay, so as of now it's still not working. We will again try. Okay, just edit this one. And let's start again. No, it's still not working. Okay, so let's refresh the page. It should work now. Okay, now it's working after refreshing the page. Now we can see that the data is going in plain text. Again, since the server is expecting the encrypted data, we are getting the data error as 400. But if we send the encrypted data, we will get this expected messages. Since we don't have the private key, we won't be able to use both the encryption and decryption. So what we can do, since server is expecting the encrypted data, we can use the function auto encrypt functionality and select proxy. So for that we need to write another encryption. So let's write a encryption. Since our data is already in the plain text, we only need to encrypt it for the server. So we will write a encryption script. So as of now, we will just copy the data. So I will just copy this JavaScript code. In our case, we don't have key. Now another thing to note is that we have this crypto.js here. Now if we just go back to the JavaScript codes, you can see that the application is using another library, JS Encrypt. That we just put, for example, you can see that JS Encrypt is another library which is used for RSA-based encryption. So we will just copy this. We'll go to our Encrypt template and we have to again install this particular library. Now if you go to the browser, you will find some example as well. So we have this example as well, which is similar to our application. So we have this browser example as well. So as of now, we will just go back to this. Okay, we have our ciphertext here as well. We'll go to the browser. So we will just copy this public key. Since we need to again encrypt the data using the same public key. Now we have to go to maybe the box suit so we can find the original code. So instead of data, we have this cipher. Instead of cipher, it should be. Now, as I mentioned, the extension will try to read the data. So we have to. So let's see if this works. So before adding this to the extension, let's verify if this works or not. So just open it. Okay, so we are getting error from the library. Now I have gone through that documentation as well, and like the error is regarding this particular library. So the JS Encrypt library which the application is using at front end is not available for Node.js. For that we have separate libraries, Node.js, JS Encrypt. So we have to encrypt this as well. Now I have already installed this one. Instead of JS Encrypt, we have to import with Node.js in JS Encrypt. Now I have updated the script as well and installed this library as well, Node.js and JS Encrypt. And we have also verified. Let me check. Now, since in our case, if I provide this, as I mentioned earlier, the extension will take the value and will give the base64 encoded value to script. We have already done this, so we will base64 decode the value which is provided to -d, and we can see that we are getting this updated value. So if I copy this, we are getting invalid request data. Now if I try, I'm getting this invalid credential. The script is working, so we have to just try to load this script. Now in this case, we are only trying to encrypt the data since we have already plain text data, but extension won't work without the decryption and encryption script. So we will provide the same script since we don't need decryption. Now we have to select the auto encrypt since data is in plain text and we want server to get encrypted data. So we will turn on. Also, in our case, that if we look at the original request, we can say that only the parameter value is encrypted. So we will select the parameter value. Now if I send this request, okay, let me select the repeater here. Auto increase on, and you can see that instead of error, I'm not getting. If I turn off auto encrypt, the same request, I'm getting invalid data. But if I'm getting this expected error message, if I go back to the logger, you can see if I turn off, the same request goes to the server. If I turn on the auto encrypt, the server gets the encrypted. Since we are using the same public key which the HTML and JavaScript code has, and using the same logic to encrypt the data, we will be able to bypass the asymmetry encryption as well without using the private key. If we have private key, we can write the same code as we did for AES encryption. Now let's try from here as well. You can see we are getting this invalid credential, and I think we can check for login successful. Now, this is just some demo example. If you just again, as I mentioned, you can download this dummy application as well. If you need some help regarding the writing the template, either you can find the custom templates as well. You can also say that we can easily write a template. We just need to make sure that our custom script handle the read the command line argument using -d, and the data will be in base64. So we have to put base64 decoding, and we should have only one print or console.log statement in our code so the extension can read it. If you need more details on how to write the templates, you can just go back to the documentation again, and you can just head over to the writing custom script. So the custom script will be the same for complete body, parameter value, and parameter key and value, since it will have the only the one parameter each time, or the complete body will be provided. In case of custom request, the header will be provided. You can read the header in case you need some data from the header. The custom request edit header will also another option where the header you can also update the header value as well. You can add new headers as well required.